In this video, we're just going to focus on learning objective A, which is factor polynomials using grouping. Now, when you do grouping, what you do is you group two terms together. For example, these two and these two. And you see if there's anything in common that you can factor out of them. So if you take a look at t cubed minus 3t squared, I can pull a t squared out of both. So I'm going to pull a t squared out, which leaves me with t minus 3. Now, the goal is, in grouping, is to factor something out of this group and this group such that this group here is identical. So now we want to look at these last two we grouped together to see if we can pull something out of it such that what we're left with is t minus 3. Well, we can. We can pull a negative 4 out of here and a negative 4 out of here. If we pull a negative 4 out, we're left with t. If we pull a negative 4 out of here, 12 divided by negative 4 is minus 3. So we were actually successful in factor by grouping. T minus 3 is the common group. It's the common group in this term, in this term. So what I'm going to do is yank t minus 3 out. So I've factored out, and then I'm left with t squared minus 4. Now be careful, you have to stop and see if you can factor anything further. This is t to the first power, so it's done. This right here is a binomial that can actually be factored further. So let's carry down t minus 3, and let's think about how do we factor this second binomial. Now the first thing we're going to do is the t squared term gets broken out evenly here. The only way to break t squared up is t and t. Now we need to break out factors of negative 4 such that when you add them together, you're going to notice there's nothing in the middle. There is no middle term. So what you do, factors of negative 4 that add to 0, if you think about it, would be negative 2 times 2 is negative 4, but when you add them, you get 0. So what I'm going to do is put the factors of that here and here. So I'm going to do negative 2 plus 2. Now I can double check if I'm right on this. One of the things you can do, it's a shortcut to check your factoring. If you multiply these two terms and multiply these two terms together, when you add them, you'll get the middle term. And in this case, there is no middle term. So watch this. Negative 2 and t is negative 2t. T times 2 is plus 2t. These two values add together to 0, which confirms there's no middle term. And this is our final answer for factoring. Now I do want to show you that you could have grouped this differently if you wanted to. I could actually have grouped the first term and the third, and the second and the fourth. So let me rewrite it. So I rewrite it as t cubed minus 4t, and then it's minus 3t squared plus 12. If you group it this way, it'll still work. What I'm going to do is actually, from these two terms, I can pull out a t. So if I pull out the t value, I'll be left with t squared minus 4. And then from these two terms, I can actually pull out a negative 3. So if I do negative 3, I'm left with t squared minus 4. Now in this way we were successful because the common binomial here is t squared minus 4. So I'm going to yank that out, and I'm going to show t squared minus 4 is coming out of it, but then what I'm left with is t minus 3. Then we would do just as we did before. We would factor t squared minus 4, and we would get t plus 2, t minus 2, and t minus 3. This answer is equivalent to the other answer over here because this is the multiplication of three binomials, and multiplication is commutative, which means you can flip-flop the order. Let's try another one. Now on this one, sometimes it's nice just to try the grouping as it's written. What if we group those two, and what if we group those two? That's not the only option though. Keep in mind, if we wanted to, it looks as though we could group these two and we could group these two. But I'm just going to go with the ones that we did in the red. What can we yank out of both of these right here? Well, here's x squared and x cubed. So at the most I can pull out two x's. So let's pull out an x squared. But then how about in terms of the numbers? That has a 9 in common and that has a 9. So let's try pulling out the 9. So if I do that, that would be x cubed, and now go to x. and 27 divided by 9 is 3, so this would be 3x. 45 divided by 9 is negative 5, and pulling out the x squared, that's gone, so minus 5. Okay. Now let's go to this part. We're trying to make it look like 3x minus 5. So notice this is a plus, this is a minus, so I'm probably going to pull out a negative. And it looks like we can pull out a 4 from both of these. So let's pull out of negative 4. So then we're going to be left with 3x. And if you do 20 divided by negative 4, negative 5. We can tell again we were successful because that term is the same. So I'm going to basically factor out that common binomial. So I'm left with 9x squared minus 4. Now this one right here can be factored further. Again, just the more you practice, the better you become. I have to equally break up 9x squared into here and here to find factors of negative 4 that go here and here, such that when I multiply this and this, you're going to notice there's no middle term here. This needs to add down here to 0x. So the trick is when you see two numbers that can become perfect squares, odds are the combination is its square root, so 3 times 3 and 2 times 2. So let's do 3x and 3x here. Now the two numbers have to multiply to negative 4, so that would be positive 2 and negative 2. So if I do plus 2 minus 2, I can confirm this. 2 times 3x is the 6x, and then 3x times negative 2 is negative 6x, and those add to 0. Again, the highest exponent I have is x to the first power. This cannot be factored any further because of that, and this is our final answer.